Hi everyone. Okay, in this video we are going to discuss about logistic equation, right? So logistic equation simply means like an equation like that. It looks like exponential, but exponential would always increase continuously without stopping, but logistic has got a limiting value. So if you were to draw a logistic equation graph, it will look like this. Okay, so let's just say we have got two variables, t being time and t can be in terms of years, in terms of months, days, or even in minutes or hours, alright? And what about PP? Let's just say it is the population, right? So how would your logistic equation look? It will probably be PT equivalent to A over 1 plus B exponent negative CT, with A, B, C being some values, right? So PT simply means P in terms of T lah, okay? Right, so what then is limiting value? Limiting value simply means that, after a long period of time, when T approaches infinity, the value that you approach, the P value that you approach will be what we call the limiting value. So for example, if you were to look at this graph, your limiting value will be over here. Means to say after a long period of time, it will become stagnant, it will become a constant, and the constant that you got will be what we call limiting value, right? So how do I then look for limiting value? We always take the value that is above, okay? But condition is it must be in the form of A over 1 plus B exponent negative CT, right? So if this is the form that you have written your logistic equation in, you're going to have your limiting value of P to be equivalent to A, right? So how then do I do it if I don't memorize in such a way? I can always go with the limit of T approaching infinity, and when T approaches infinity, you're going to have exponent negative CT to approach 0. Yeah, we all know that because we all know to draw the graph of exponent negative x, alright? So if it is exponent negative CT to approach 0, B exponent negative CT would approach 0 for sure, hence 1 plus B exponent negative CT would approach 1. So if it is 1 that you're approaching at the denominator, your PT would approach A divided by 1, and hence it is A to give the limiting value, right? So let's look at an example. This is an example in your book already, and we have discussed this quite a number of times, alright? So you are given a differential equation, dn over dt equals to n over 4 minus n squared over 8,000. And I told you the initial value of n, so when t is equals to 0, n is equals to 4t, right? So what are the two parts that I wanted you to do? Part A, find nt, okay, means I needed a function of n in terms of t, and second, find the limiting value of n, means what is n when t approaches infinity, right? So how should I work on the first part? Okay, dn over dt equals to n over 4 minus n squared over 8,000. Note that differential equation for logistic equation always looks like that. Okay, you're going to have an n and you're going to have an n squared, right? So I call this the differential equation. How do I solve differential equation? Before I could solve a differential equation, I got to first be able to separate my variables completely. So as you can see, I've got two unknowns. I've got two variables, one being n, another being t. Okay, so dn over dt equals to 2000 n minus n squared over 8,000. When I want to separate variables completely, I'm simply wanted my n terms to go with my dn, and my t terms, if there is any t terms, to go with dt. So for this case, I actually flip both sides of my expression of my equation, and then I got something like this. When I look at this one, 8,000 over 2,000 n in bracket n, there is no way I can integrate it just like that. Hence, I know I got to be using partial fractions to rewrite such an expression. So how then do I use partial fractions? Okay, so when you look at it, okay, the first thing you do before you could find partial fractions, okay, would be to factorize your denominator completely. So when you look at it, if I were to factorize it completely, I'm going to see two linear factors, one being 2000 minus n and another being n. Right? So when you look at it, it is a over 2000 minus n plus by b over n. Right? Then I'm going to make my denominator common, hence I'm going to go with 8,000. If I were to compare the numerators, I'm going to have 8,000 equals to an plus b in bracket 2,000 minus n. Right? So how then do I look for this a and b unknown? I'm going to go, when n is equals to 0, I'll have 8,000 equals to 2,000, b and b would give me 4. Why did I let n equals to 0 is because I needed to get rid of either a or b, you see. So when I let n to be 0, I'm going to get rid of my a, right? So what happened next? I'm going to let my n to be 2000. Why? Because I want to eliminate my b, right? So I'm going to go n equals to 2000, 8,000 would be equivalent to 2000a, and that is when I'll get my a equals to 4, right? So the equivalent, okay, the equivalent of, if you were to look at 8,000 over 2000 n, minus 2000 n minus n, okay, it will be equivalent to writing 4 over 2000 minus n plus by 4 over n. Okay, so bringing these partial fractions, I'm going to leave it here. And that is when you know I can actually integrate it like normal already. So how do I integrate? What formula do I use? I am going to make use of this formula. Integrating f prime x over fx respect to x would give me ln fx plus c. This is the formula that I'll be using. So when you look at it, okay, it is 4 over 2000 minus n. Hence, there should be a negative 1 on top. Hence, I'm going to leave my 4 and there is a negative, and hence it is ln 2000 minus n. What then about 4 over n? If I were to differentiate n, I'll be getting 1. Hence, it should be plus 4 ln n. And 1, when you integrate it with respect to t, it is just t plus c. There is no need to put c on both sides, you see, because c are both constant and they can get adjusted easily. Okay, so it is just one c on one side. So I'm going to combine this ln. Okay, 4 I have pushed over to another side. Hence, it becomes t over 4 plus c. Okay, don't bother dividing c by 4 because again, c is just some constant that we do not know value of. Hence, you can always leave it as a c, right? So 4 is no more there. I'm left with negative ln 2000 minus n plus by ln n, you see. So then I'm going to use logarithmic law. Then I'm going to combine the ln in such a way that I've got my ln to be n over 2000 minus n. Okay, so if this is what I got, the next thing to do is to exponent both sides lah. Because my intention is to look for nt, means n in terms of t, right? So how do I release my n over here? I go to exponent both sides. So I'm going to exponent both sides, and hence I'll get exponent t over 4 times exponent c. And I've let my a to be exponent c. Right? So my job now is to look for the big A. Like, what is this big A, right? So by using the initial value, t equals to 0, n equals to 40, I should actually arrive to A being 1 over 49. So sub your A to be 1 over 49, and that is when, like, you know, you are going to rearrange accordingly and you will get your n to be equivalent to 2000 over 1 plus 49 exponent negative t over 4. And this is exactly the form I wanted for a logistic equation, right? So what about for part B? Part B says find the limiting value of n. So how do I look for the limiting value of n? I got to let t to approach infinity, you see. So when I look at it when t approaches infinity, exponent negative infinity is 0. 49 times 0 is a 0. 1 plus 0 is a 1. Hence, when t approaches infinity, n approaches 2000 divided by 1, which is a 2000. So it means to say after a long period of time, I'm going to have my n to approach 2000. Okay, and that is about logistic equation. And note that it has always been in the past year that logistic equation is tested in race, so make sure you know logistic equation. And in logistic equation, you will need to also know 2 skills. And what are the 2 skills? You must know to do partial fractions, and second, you must know to separate variables completely to solve differential equations.